Now, what is ModusPonens and ModusTollens? These are Latin, and ModusPonens, it means method of affirming, which means the conclusion is an affirmation. So let's write down the argument ModusPonens. So we have if P then Q. This is the first premise, and then the second one P. Therefore, the conclusion Q. So the conclusion Q is an affirmation of the premise P. So this kind of argument is called, this format of argument is called ModusPonens. And ModusTollens, the Latin meaning is method of denying. It's a method of denying, so the conclusion is a denial. So let's write down the argument form. If P then Q, not PQ, therefore not P. So the conclusion not P is a denial of the based on the premise. Premises. So we have, for both ModusPonens and ModusTollens, we have two premises and one conclusion. But in general, any argument could have more than two premises. Now let's look at how we use ModusPonens and ModusTollens and to fill in blank to finish this argument, to make it a valid argument. First, we have a conditional statement. If there are more pigeons than there are pigeonholes, then two pigeons roost in the same hole. Actually, this is one of the principles in discrete mathematics, which is called pigeonhole principle. Okay, so the number of pigeons is more than the number of pigeonholes. So if you think about it, and if you put one pigeon in each pigeonhole, and because there are more pigeons, you will have one left. And where will you put this one pigeon? You have to put in one of them. Doesn't matter which one you put, which hole you put the pigeon in, and this hole will have two pigeons, or even more. So this is the first premise. Now the second one says there are more pigeons than there are pigeonholes. This is a fact. So number one is sort of like a principle, and number two, and in a certain in a specific situation, and you counted, you have more pigeons than pigeonholes, and following the principle, pigeonholes principle, first premises, the conclusion we can get, it must be the conclusion of the conditional statement. So we will say two pigeons must roost in the same hole. Okay, so this is ModusPonens. The conclusion confirms this conditional statement. So this is pretty much the same conclusion as the conclusion of the conditional statement. Now let's look at the second one. If 870,232 is divisible by 6, then it is divisible by 3. So this is the first premises. This is the hypothesis, and this is the conclusion. And now, another premise we know, suppose we know 870,223 is not divisible by 3. what conclusion can we get? So if it's a negation of the conclusion, then we will get the negation of, I should put therefore here, therefore will be the negation of the hypothesis. So we negate the hypothesis. 870,000 is not, 222 is not divisible by 6. Okay, well, so the first premises is also one of the sort of like properties in number theory. If a number divisible, any number, actually not only just this number here, any number, if it is divisible by 6, then it should be, which means that this number contains 6 as a factor. But 3 is a factor of 6. So of course 3 is also a factor of this number, which means this number is divisible by 3. So this is a property in number theory, which we know it's true. And number 2, we can actually check, we have a rule that we can check quickly if a number is divisible by 3. You add all the digits in this number, 8 plus 7 plus 0 plus 2 plus 3 plus 2. So you will get 8 plus 7, 15 plus 2, 17 plus 3, 20 plus 2, 22. And if the sum of all the digits is not divisible by 3, then this number is not divisible by 3. So apparently 22, the sum of all the digits is not divisible by 3. You can say this number is not divisible by 3. Therefore, by ModusTollens, we know that this number is not divisible by 6 either.